All right, welcome everyone at the Multi-Network Community Sync. Today we have September 20th. We don't have much of a agenda, but maybe I think Victor joined today and added some idea that we can disaster recovery to talk about. So maybe take some more time. But if you have any other topics, please add them to the list. By the way, the minutes doc is in the invite of this meeting, and you can just, everyone has an edit, right? So you can add yourself and add an item to the agenda. Okay, let's go for the first one. So this one was kind of brought up by Pete in the doc. He reviewed the doc and point out one kind of aspect, maybe somehow related to the disaster recovery, maybe not. So a use case was maybe in the design doc, what we currently have is that if someone deletes a network, the network will be put in a delete in progress state. The ready will be set to false. And when ready is not true, no new pods can attach to that. What to do in a case where we have an existing deployment running? A scenario that I think, and Pete, correct me if I'm wrong, or maybe you can just give the scenario that you have in mind, and then we can.
Yeah, so I'm just thinking of what would happen if, let's say we've got a network that's being created, and I've got some deployments that are using that network. Everything's running happily, and then I either decide I want to get rid of the network or I accidentally delete it. So nothing immediately goes wrong. Just the effect of the pod network is now in a bad way, but it means that I can no longer schedule any new pods, because the pod network is in a pending delete state. And that's bad because it means that all my deployments are now in a state where they've no longer got any redundancy. If one of their pods fails or gets restarted or whatever, then it's not going to come up because you can't create new pods on that pod network. And there's no simple way of getting yourself out of this state. You could obviously create a new pod network with the same parameters as the old one and then start changing your deployments to point to that. But if you accidentally delete a pod network, it's quite a nasty position to get yourself out of. If the pod network would go away, you could recreate it. There's things you can do there, but it feels like maybe we could make that more robust. I mean, having some kind of undelete would be possible, but I don't think that fits in very well with the current API model. It's possible that the right thing to do, I know that I was the one who suggested that we should just have it in a delete in progress state originally, or at least I was one of the people in those conversations. But I'm now looking at it and thinking, well, hold on a minute, actually, this has got some nasty edge cases.
Yeah.
Maybe the right thing is to say that you can only delete it when it's not attached, but maybe we have a case where you can mark it as you can't attach to me in the meantime, so that you can drain all the pods out of the pod network. Or maybe we just go back to the simplest thing of saying you can only delete it when there's no pods attached. And yeah, there's a small window there, but it's a very small window.
So looking at other use case, let's kind of explore that. So let's get rid of delete in progress, right? Deleting will make the accidental or a purpose deletion of an object would set a delete timestamp. This is a metadata object in Kubernetes objects that will indicate, and this is how all the controllers kind of look at objects that, oh, you want to delete this guy, right? That's basically across all objects in Kubernetes, so that there is a delete timestamp. I'm not sure how much of you are aware of that. Just that everyone is on the same page. This metadata field indicates explicitly and very clear that, okay, someone ran a delete method on this object and wants to delete it. So whoever creates a controller usually will just check, is that field non-empty? If that's the case, okay, someone wants to delete this object. So we have a clear indication from the API on when this happens. I was planning of reusing this field to say, oh, someone's trying to delete it. I will put ready false with this error, with this message, right? But let's explore a case where, okay, we don't do that. Ready is ready because we didn't change any other parameters, right? Like if I reference another, if I were to reference something and that got deleted, then yes, then clearly I would put the ready false because the params not ready with case will be triggering here because I cannot find the or maybe now that would not happen. I will not from API point of view, and let me correct my statement. From the API point of view, I would never check the parameters. Sorry, that's I went into wrong. Your implementation will have to mark the params ready condition false, and that will make the whole network false, right? If you implement that in that way, and I would consider that a correct way. So when you delete that referencing object, right? So in that case, network will went ready false, no new pods can be created. So that's something that basically obvious and we shouldn't touch on that. But now if I accidentally deleted the network, it's marked as in deletion progress, but it's in use, so it's still there. But readiness doesn't mean it's not ready, right? Because ready means basically that the other object is there, whatever I'm referencing is everything ready. I pass all the validations, and that's still the case even if you delete it, right? So from that point of view, we could say that why do we set it ready false, right? So let's keep it as is. So the problem with that one would be, how do I mark something that I really want to delete? So maybe what you, Pete, said is really what we need to have is drain. Maybe we should have a drain equals true field in here to state that, yeah, I want to start draining this network. Don't create anything new. I like that idea. Maybe we should do something like that, where instead of just relying and automatically stating that if you delete, then that means don't make ready false. I would say let's maybe put a flag called drain or something like that. Let's follow the path that node does, and then we can clearly indicate, yes, I am deleting it explicitly, and yes, I don't want to have any more networks on it. Maybe that should be the case, right? And that would solve everyone's problem, right? So accidental deletion is not a problem. You deleted it. Be mindful that it will get removed if all the workloads go away. So Pete, in your case, let's say I'm upgrading a deployment. No, you would be probably safe if you have a max search of 2 in a 10 replicas of the deployment. You would just update 2 at a time. So you would never be able to run out of pods for that network.
Yep.
So it will be always in use. So you would never be able to delete it, right? But then if I really want to do that, that's my explicit goal, to kind of get rid of the network. I can just put a drain on it flag. And then that way I can indicate that, yeah, at this time I do want to delete it. I don't want any new workloads on it. And eventually I want to just
So putting that together, we'd only allow deletion if no pod was using it. But in addition to that, we've got this drain model where you can say, I want to get this ready to be deleted. So I'm expecting everything to be deleted. And then and the use case that I'm nervous about is the one that I inevitably get dragged into, which is some customer has accidentally deleted something and a bad thing happened. And if they've accidentally deleted it and nothing was using it, well, that's harmless. They can recreate it. And if they've accidentally set the drain flag, well, they just switch it back off again.
Yeah, exactly.
Things will recover. So it feels like the risk of a customer shooting themselves in the foot has gone away, which is what I'm really worried about.
Is drain? Does that mean it'll start removing pods from it? Is it or just block? I mean, is there a difference between drain and cordon? Cordon on the node is
yeah, that's the same. I would say.
Yeah, I think it's cordon rather than drain. Yeah.
Yeah, that's what I was thinking.
It's
specific about the syntax.
Yeah, thank you, Kevin. As I mentioned, same model as what Node has.
Yeah, Node has both cordon and drain, doesn't it? So cordon is you can't add any more. Drain
no,
is
I think
throw out. Is that not right?
No, you put cordon and uncordon to a node. Drain is that's what we just say and call it colloquially,
Okay.
but I think it's cordoning.
Yeah, yeah. Cardon, I think, blocks new stuff arriving. Basically.
Yeah, exactly.
Yep. Okay.
And how that's going to be realized, there are taints on nodes, so I will have to look at, I don't think we want to add taints to a network. So there will have to be some sort of like a just a field, maybe cordon field in a spec that can be flipped back and forth.
Yeah,
Maybe
we already have some checking where we look at a pod to decide whether the pod network it references is valid. So I think maybe it's just another check in there.
No, that has to
But
be a
maybe-
field on the object, right? So if I would set the field true, by default it's false. But if I set it to true, I set the ready to false, right? Basically, that means that okay, pod is not ready, and I would just control the readiness, and then in the reason I would say cordoned, right? No new pods, and that's how I would control it through this. So that there is only one point that all the implementation has to look at. No implementation should look at this new field. They should keep watching only the readiness of the object, right? And that way it's easy to kind of whatever happens, whether the parameters goes away or this being set, I can easily determine that oh yeah, this network is not ready and I cannot add any new things for it. So you have one place to look at it rather than multiple, right? So I would still just use readiness as a control, external control for everything else that looks at this object to identify whether I can add pod or not. But then this flag would additionally control that readiness flag, right? Any other comments to this?
Maybe a question, Maciek, is that so that it does it mean that a delete can only happen when everything is drained, or is that a check?
So yeah, so in use, right? So basically, every time you were to delete a pod from a pod network, right? There will be a check of there is the in use condition, and I would see the controller checking for pods, right? So every time you delete a pod, I will check is that the last one, right? If it is, then I would remove the in use condition.
No, but my question is more on the network itself.
Okay.
What on the network? So you do the cordon, right? Cordoning.
Uh-huh.
So let's say I do accidental delete.
Mhm.
You can still do so, in my view, right? Because unless we in the API we do a validation that you cannot do a delete unless the drain is unless the cordoning happened.
I talked with Antonio on this one, and we would not want to do any custom stuff for some objects, right? Because that's what you're probably asking for. So we still have to work within bounds of current API machinery. And that's what I'm trying to do. So basically, if you look at my dog, for example, how I'm handling the default network, right? I mentioned that last week. If someone accidentally deletes it, there will be just a small controller that will just remove the finalizer, remove the object, and recreate it. That's the only way to do. You see how it's a bit hacky, but there is no way to just there is. It's all code. You probably can program, but they wouldn't want to create new, API machinery, some new paths for some objects, right? So instead of doing that, just let's reuse whatever is there in a ways that kind of use the existing components. So yes, you still can accidentally delete an object, delete a network object. You still have to do it. Otherwise, how you would control whether I really want it or not? You could now with this, if we had this new field drain, you could say that okay, until that guy is drain flag true, only then you can set the deletion in progress, right? Could be a case, but then would require additional handling in API machinery to ensure that you never set the delete timestamp, right? For those objects, unless that. So that's additional code paths that I think I was recommended not to do any custom API machinery.
Well, I'm wondering whether we can do it through the validation webhook or something like that, without changing a custom validation web.
So validation webhooks definitely could be done by externally, by implementation directly. Those can do that, where basically validation webhook can check, oh, it's a deletion event, oh, it's in use, and reject such call, right? You could do that,
Yeah.
right? Can we do it in core? That's something that I'm not sure, right? Why not? How do you, maybe
It's just a
that,
question. So
yeah.
and just the question is how we can prevent. So that's one way to prevent it, but I don't know what the implications are.
Right. Implications, I think on that one, since that will be part, because any this is a core object, any webhooks will be part of the core API. So it's not like you can disable that webhook, right? But
Yes.
on the other hand, what if you really want to delete it? Let's say you want to get rid of this. How would you do it?
You need a force flag or something like that.
Exactly. How would you force deletion? Because if I create that webhooks, there is no way, because if I create a custom webhook, I can disable the webhook. If I add it here for this core object, there is no way you will be able to delete this object unless you delete all the workloads. And imagine you have 1,000 pods on this, and you're stuck.
And maybe it's too much, right? So I'm just trying to see.
Yeah. No, it's a good idea. That will definitely prevent. We could have the deletion timestamp, but let's look at the consequences, right? Because then you really cannot delete it. The webhooks will, if it's in use, you can do nothing. You don't have access to those controllers and webhooks, because those will be baked into your API and KCM. So basically, you will not be able to do much here. It's like in terms of explicitly disabling so that I can hack it. So
the only thing I
really...
can think of the only thing I can think of in that case is you have a force flag, right? So delete force will override it or something.
Yeah,
like but okay,
flag.
yet another flag. Flag.
Yeah. So that's kind of and with this, as we have it right now today, without the webhook, yes, it would get set in the it will have the delete timestamp set, right? So eventually, with time, it can go away if by any chance it will be at any point not in use. So it might get removed. So maybe if you accidentally deleted it, then maybe what you should do is
I think the key question is what Pete asked in the beginning. Do we still allow scheduling of pods, right? Because that's, I think, Pete's original concern was, let's say someone accidentally deletes it, and a pod goes down on that network and needs to be rescheduled. Will we allow that? I think that's
so that
probably
part
the
we said
first question.
Yes, right? So this, right?
Okay, if that happens, then probably this is probably not worth the effort, I think.
So you can still have it. The problem here would be, what if, I have a production, accidentally someone set the delete flag, right? So set the timestamp, right? Set the timestamp to some value because accidentally created that, right? And by any chance, I don't know, a node went out that has all the pods running using this network. And the API saw, okay, no more pods on this guy. And because the pods were removed or something, and the AP machinery saw, okay, no more pods on this thing, I will just delete it, right? Because it was no more workloads, right? So I'm removing the finalizer and it goes away. And your running production suddenly just crashes because all the new pods that's supposed to use this network is not there. Right? That can happen. That can be a case, right? Where someone accidentally deletes this, and then in delayed time, let's say in a week or in a month, you come in and see, oh, the network is not there. What the heck? What happened? So that might be a side effect. But
I consider this personally as a corner case more, right? Because running
That's
all the
true.
pods on a given
That
node.
is a corner case, right? So this is where it might be tricky, right? On what will be the best kind of middle point of this whole thing, right? Or maybe we shouldn't even maybe delete this then. Prevent deletion. If you delete it right away. But then what about the existing pods, right? That's something that I think we cannot go that path. I'm trying to explore various cases how we could, because that will be the kind of the like pod. I can just add a remove pod, doesn't matter, right? And deal with that. But basically here, this object is dependent. So on the other hand, if we look at the namespace, right? If I delete the namespace, I delete all the pods in that namespace. Should we maybe just follow that example? If you delete this pod network, I am going to delete all the pods that are assigned to this pod and delete the pod network. Maybe we should do, because when you think about this, namespace is similarly critical, right? You could accidentally delete a namespace and that will delete all the workloads over there, right?
True. See, to a certain extent, I mean, accidental deletion you could think of should not be allowed, because you should have protection in place on your API to prevent that.
Exactly. So when you think about that, right? That's because I think that this last thing that I just thought of might be the solution, right? Because when you think of this is the pattern that namespace does, right? Because you put networks
correct.
in namespace, and they are children of that namespace. So basically, if you delete that thing, we can make any pod attaching, and a pod network is becoming a child of that pod network, right? And then whenever you delete that, I'm just gonna delete all your workloads and then delete the pod network, and then don't deal with all this deletion in progress, finalizers, and all that, right? We could do that.
Yeah.
Or the finalizers are just
I'm a little worried about the implications of deleting a pod network being deleting a vast number of pods potentially. Just how it's the usual customer fat fingering thing that worries me. But it's very, very easy to
how do you prevent namespace being deleted, Pete? The same problem, isn't it?
I think it is less likely that that will be cluster wide. I think it. So I'm nervous about that as well, to be honest.
Yeah. So
sure
and
namespace, so I don't want to introduce more.
Namespace is NS, right? So it's even shorter, right? So you had delete NS, whichever, and you're done, right? And basically that can be the same problem, right? So because then that simplifies things a lot, right? If when you delete network, we delete all the associated pods with it, and we can be done with it. I think with namespace, it's more of a structural. You have folders, and then you have the children for that folder, and that's why if you delete the folder, you delete all the children, right? So that's like folders and files, kind of paths in Linux or something. So you can look at it from that perspective. I assume that was the reasoning behind here. You attach, right? So it's not really children, because you can have across multiple namespaces those attached, right? So that's slightly different, right? So that's why we want to do this different mechanic, and this will be a new machinery, or maybe a new pattern how objects behave, interact with each other in core, right? Because that's what it is. But some folks might say it's too complex, and then we get a pushback. So we'll see when we're going to talk with a wider group, but that might be a case, right? So some might say, why this is so complicated? It's too much machinery, right? And those edge cases that you just brought up, and there can be probably 1,000 more, right? So maybe for that reason.
Yeah, it might be wise to wait till we've got some feedback from people actually using this and see what they find convenient. The other thing that occurs to me is if you have a model where you delete the pod network and that takes out all the pods, that sounds that actually doesn't sound so unreasonable now. But what about in future when it is possible to delete a pod network from a pod? If we have a later version where that is possible. that stage, then the behavior you would want would be to remove the pod network from the pod, which would seem kind of reasonable.
Yeah,
Oh,
I think that's the ultimate thing. You just delete that network from the pod, right? So if we have the ability to plug dynamically, then you would do that, right?
Yeah.
That's then you mutate a pod. That's a big discussion probably in itself, right? Because you mutate a pod, right? Before you had it, now you don't. The pod in a spec says I want to connect to this pod network, and then externally you can change the spec. So that's that's kind of tricky. Unless you it will be a different story if you explicitly change the spec, stating, okay, I don't want to connect to this network. That's cool. Okay, that probably is fine. But then I deleted the pod network, and you went and modified my spec for my pods. Oh, that's a big deal, right? So if you think about this that way, so all right, I think the drain. I will try to look into the drain field. That will, I think, somehow cover at least this use case. There are some different use cases, as I mentioned, the delayed deletion. But I don't think we can handle that. We can cover that one, right? Let's propose with this delayed deletion with the drain capability, and see how the rest of the community, what the rest of the community thinks about this.
One thing just to add is we do have our story number 8 as part of our requirements, which is that the ability. Yeah, hot plug. Because I was figuring on using that, but yeah, I mean, it's a tough decision. I see it from numbers perspectives. Like if somebody deletes their default network and then they delete all of the pods on their cluster, right? There's that. And I was figuring whatever implementation would probably have something for story number 8, right? That it like has a controller for these, etc. But it does sound complicated to mutate the pods based on the deletion of the networks, etc. So yeah, this is a great discussion item. I'm glad you brought it up, Pete, or whoever did. I thought it was Pete, but yeah, good stuff.
So Doug, to what you said, one more thing. As I mentioned, right? Oh, default. You mentioned default network being deleted. We would behave same way as default namespace. I have to test. That's easy test. I'd create a pod in default and delete the default namespace. And what's gonna happen? Do we delete the pods? Because we probably could do some special handling for this case, where if you try to delete the default network, as we just were gonna recreate it, we could maybe then skip deletion of all the pods. Something that would have, we would definitely just follow the default namespace behavior, right? On this fact.
That makes sense.
The bit that I think might be problematic technically is if you ever have a pod that is a reference to a pod network that doesn't exist, and then you try and delete that pod, one of the things that things like CNI usually do is they need the config for that network in order to correctly tidy up the networking left over from the pod. And so if you delete a pod network, you might find that you've leaked a lot of resources from it. Maybe that doesn't matter because you've deleted the pod network, but if it's a logical network, maybe it does.
And I love that you brought that up, because certainly thinking about it from a like CNI wise perspective, certainly the way I was thinking about implementing it CNI wise was to, no matter what, still keep the cache of what you were going to do with CNI so you could get that proper delete. And I mean, there's improvements coming for CNI for garbage collection, but it's like you got to do your best to clean up the garbage there. So
sorry, I might have missed, Pete, what was the use case?
So if you have a pod that's attached to a pod network and it's had its network set up and you're using CNIs somewhere down the stack, the implementation, when you delete the pod, the CNI has to go and delete the resources. So get rid of the network interface and or whatever, one end of a VNet pair potentially, whatever routes, all of that stuff. And all of that requires you to know what configuration that pod was created with. And
Right,
if you've
so-
lost
so-
those links,
so-
then that is a problem.
So
I don't
keep
know
in
how
mind,
much we care about that, but it's definitely a problem.
so the finalizer will still be there, Pete. So and basically you would never what I want to say, until I delete all the pods, I will keep the finalizer on. So basically your CNIs can reach out and get the pod. So you don't, that's guarded basically. So that's kind of, you have the guard around with the finalizer to prevent that. But the finalizer is not permanent and doesn't wait for some in use to be removed, because there is action, ongoing action towards removing the finalizer. That's the big difference compared to what I said, this delayed side effect, where there is no actions, and basically it's a slightly ticking bomb over time where it can blow up where as soon as in use is removed, right? So that's the difference, right? And compared to, I clicked, I set off the timer for that ticking bomb basically, right? Where, so you have a kind of estimate time when it's gonna kind of finish, right? Compared to you don't know when. So that's the difference. So, and the object will be there, so you don't have to cache, and the CNI should be able to then get it all. CRIs will see everything. We should, that's why the finalizer is there, so that we never had a case where, okay, this guy went off, but there are some things dependent on it. If that's the case, you either, and in that case as well, there is a always the implementations always can add their own finalizers on the object as well. Just keep that in mind, right? Like there, even if you remove all the pods, okay, I need to, let's say, disconnect switch or something. I need to do some other, my implementation does some magic and has to do additional things, and you cannot delete until I did those things. So I put my own finalizer on top of it yet again, so that the object doesn't go away. So there are means to that to kind of handle that. Right, I think the decision is to kind of introduce the drain flag and remove the ready will be kept true when someone deletes the object, and when only when I explicitly want to, okay, don't put don't add new pods to the pod network, just set the ready to false. Any other comments on this? All right. Peter, I think that's you. You're muted.
I am muted, yes. I've got a couple of slides, so I'd quite like to share these. I don't think there's anything very, I'm not going to do a demo or anything like that, but I've got a couple of slides that show what we did and what links are.
Let me give you
so hopefully this.
My co-host. Yes, there you go.
Right, so let me do that.
Let me stop sharing. Not recording. Stop sharing. Okay, there you go.
So let's try share screen. Is it going to go with that? Can you see my screen now?
It's loading. It's black. Oh, there it is. Okay, we got it. Yes.
Cool. So this is just okay. So this is just a very quick summary of what we did in our hackathon. So a little bit of background on this. Microsoft have an annual hackathon. So we decided we were going to see if we could implement the whole of multi-network in a week with a group of people who've largely had never touched Kubernetes code before, and some of whom had never used Kubernetes before. So that was quite fun. So let me a little bit of a summary of what we actually did. So the thing we ended up doing, we implemented the core API. So all of the resources we've got here, pod network attachment, the pod spec and pod status changes, we implemented all those. I say we implemented all those. Syed implemented all those while I watched him. Every project needs to have a really good developer on it, and he was that for us. And the bunch of things we didn't do all the hard stuff. We didn't own any controllers, no validation, status fields we're not doing anything with. So we just hacked our way through that. And we came up with an implementation. So there we just used Multus. Now Multus, as you know, it takes annotations in the pod to decide what networks to attach it to. So change Multus so that it would look at a pod. If there's no annotations in it, it would then go and read the pod network and pod network annotation links, follow them, collect the resources, and then chain down those to get the custom resources linked to from the pod network, so that it would do all the same building. There are lots of limitations on that as well. There's no error handling. We haven't got any default network. It just always put that in regardless. And we didn't do anything with pod status. It just writes the annotation the way it always did. And there's no pod specific configuration. So we didn't get all the way through to doing everything you could think of doing, but we got quite a lot of stuff. And we ended up demoing, we had kubectl to set up the new resources, to set the new fields in the pods, and then we demonstrated that you can create pods and Multus would set up the additional networks in them. So the reason I think this is interesting is the next steps. So we implemented the API. So we have some API implementation code. So whoever is going to implement the API code for this KEP, we've done some part of it. You should probably look at what we did as a start. Maciej, I know you'd done some initial, you had an initial branch. We cherry picked your commits to start, and then Syed added some more stuff on top of it. So I think that link is worth having. And the other thing is, we obviously did a Multus implementation. It might be worth pursuing that. It might not. We didn't. That's much less sophisticated in terms of it's fairly hokey code. But I think the bit I think that I came away from it was with a bit more confidence that, hey, this stuff is real. You can actually make all this happen. You can create pod networks and actually have pod networks with extra network interfaces being added to them. And we didn't really come across anything that didn't work or seemed wrong as far as we got. So it's quite positive. A few links here. The Kubernetes code and the Multus code. We do have a bunch of scripts and demo stuff, but unfortunately that's all Microsoft internal. I can sanitize, there's nothing exciting in there. I can sanitize them. It's just that we probably don't want you to know the names of our internal VPNs and stuff like that. Sure. So, but if anybody wants to see that, or if it would be useful to people, I can pull things out and send you some shell scripts and stuff.
This is awesome. Thanks, Pete. Yeah. Any other kind of? You said everything's working, so that's very positive. I wonder whether there are any other side effects of what we're trying to do.
It seemed to work pretty well. It didn't. I mean, we didn't get into a lot of the more complicated parts of it, but as far as I could see, it was very straightforward so far. I mean, we've only done, in terms of having a full implementation you could put into production, where 2% of the way there or something. In terms of something we can demo that does all the features, we're maybe 10% of the way towards there. But I was left with quite a good, confident feeling about it, and it's quite nice to have something we put together. If anybody wants to do what we did or to take it, then I'm more than happy to. I mean, the code is largely there; it's on GitHub, but I'm also more than happy to help people set it up or take it further if they want to.
Any chance you can link this or just those links into the
notes? So these slides are just in a Google Doc, so I will just pop them into the chat.
Okay. I already typed them out, so I'll throw them in chat here while we're there.
Yeah. So what I'll do is I'll grab a. Oops, if I can. Let me get.
All right. This is awesome. Thanks, Pete. Yeah, proves it's possible. And so I need. Should I just try this? Yeah, let me just try this.
Yeah, I just want to say, yeah, thank you for spending the time on this. I'm extremely interested in it, and yeah, pass along my thanks to your team. I definitely want to give it a try. I think that Tomo might have a recipe for a custom Kubernetes build, but I have not done one in a few years. So I'm gonna give that a try as soon as I can. And yeah, I just appreciate all the work that went into it. And I think from a Multus perspective, we're still trying to figure out like what's the best next steps. I mean, there's part of me that thinks, Multus could be adapted to this reasonably, which I think that you've kind of proven that it's possible. But I also want to kind of socialize with the CNI community some more and see like, does this fit into a CNI 2.0 / CNI.next paradigm?
Agree.
Yeah, because
we had Michael here before, but he didn't. I hope we do, considering Michael was Michael Zappa was always here, and he was I think favorable towards what we are doing here. So I'm hoping that will be a positive as well kind of take on this.
Yeah, absolutely.
But I agree with you. We should have the CRIs and CNIs aligned as well to kind of pursue this, so that we know that again they eventually kind of catch up, providing the CRIs API, so that we can instead of us directly going to the pod, CRI can give all this to me, right? At least the names, right? I don't have to get the whole pod with all the data. I can just they can just give me the names. And then I can, based on that, I just get the objects themselves. I don't have to get the whole pod. But might be tricky for pod attachment if I have the pod network attachment. This is where the probably tricky part might go in. But yeah. All right. Any other questions or comments on that hackathon stuff? All right, we have 15 minutes, Victor. I hope that's at least we can kick it off, the disaster recovery. I would want to, maybe I'm disaster recovery. Can we define what that means?
Yeah,
that's something that maybe that's where I'm missing a bit maybe of context. Maybe this is a common thing. What does a disaster? Can we define what a disaster is and disaster recovery is? Maybe that's what I'm missing, and that's why
I think it's probably starting from where I started from. I'm a traditional like database guy, database consultant working on traditional databases. So for me, disaster recovery usually means having a database backup, and the backup is immutable; it cannot be deleted. And then you also have a if the database is running like in New York data center, and if that data center got flooded or whatever, a fire, and that whole even that whole region got like flooded, then that data center, that database, together with all the middle tier and applications, will run in Chicago. So basically, disaster recovery is just one whole region is no longer doesn't exist anymore. How do you get everything up and running in another physical location?
Sounds good. All right, so we definitely have to reduce the scale here, right? Because what
in particular to Kubernetes, it started again about, for me, I'm just saying, okay, how do I run Kubernetes, a database on Kubernetes? So then, just like actually the first discussion that you've been talking about is really relevant, like deleting progress, deployment, because in Kubernetes there are at least for database, it's very common, I guess, for most workload to automate it, the application management using the operator, Kubernetes operator as a pattern, right? And in addition to that, there's just so many different ways to provision, manage the resources, using the traditional manual process versus, class API. In the cloud, there'll be cloud provider. There's all kinds of different things involved. So to simplify it, let's say just this on-premise, just a two virtual machine, because a virtual machine and bare metal is a little different. Let's say start with a virtual machine. If I have a virtual machine in New York, another one in Chicago, and a bunch of virtual machines, running on top of it, we have a Kubernetes cluster running. So if New York site goes down, how do we get it up and running there? So have a whole thing goes down is possible, but let's say if it's they're using someone's doing delete network and then and delete the pod at the same time. So other than storage need to be there, need to be replicated there. The operator need to know the application specific characteristic. On the network side, what kind of a networking need to be put in place to make sure that first of all the pipe is available for before it goes down, that all the data should be replicated there, and then DNS need to be transfer, pointed to the new site once the primary site goes down, and then for the users who log in remotely to the primary site, how do they got transferred, connectivity transferred to the new site, and of course including all the load balancing, API gateway, whatever networking component is needed as part of that disaster recovery
So I think you're going very deep into the core components of Kubernetes, and probably this would be then the topic for SIG networking, going, or maybe even API machinery, to go and talk about how do I recover a control plane failure, right? I would not want to go there in this meeting. Let's, like, if we could, let's focus on multi-networking aspect of this, which is basically limited to CNIs, right? So what would happen if I have a cluster, I have multi-networking enabled in one of the nodes, right? Something that we today don't support, by the way, at least on this phase of first phase of multi-networking. We are not looking on a what I'm calling a selective availability of a pod network. Today, we assume every pod network is available on every node. And this is just an alpha, and that's why it is like this. We have a phase 2 where we want to introduce the selectiveness. And in that case, what do we do then, right? Because then, as you said, I have Chicago and New York. And let's say New York only has access to this additional network. What do I do then, right? Definitely, I have centralized my API. I believe in that case that, and that's why I don't want to go into that path. Let's assume the control plane is resilient, right? There is no disaster. It has its own free nodes across zones or something. And if some zone goes away, I have two other ones that are that are up and keeping the API available. So let's assume this is stable in this disaster case. But what happens if basically the specific network goes away and it's not available on my on the one of the other sites where my VM is? So in that case, depending on how the networking is configured, right? Because if let's say New York, where the disaster happened, had a connection to, I don't know, my backend network local to New York, how do I then restore that thing in Chicago, right? Is that even possible? And that's kind of a question to infrastructure, right? At that point, do you make sure that those are redundant, those connections across the board, so you can have, like, let's say I have backups in New York and maybe some in Chicago, or they both the backup is connecting to something in maybe Boston, so that it's even further redundant. And right now the connection is the VPN, let's say, is connected only to New York. How do I ensure that this VPN switches back to the Chicago place, right? So do I do that? Do I worry about it? So that's something that, again, falls into infrastructure, right? So I don't think we
actually.
Yeah.
Sorry. So the Endly network, I think it'd be out of scope, because there's all kinds of solutions that, how many pipes, physical pipes are needed, right?
Yes.
So I think it's more of on the Kubernetes level, on the overlay network.
Okay.
So how do we, let's say, what kind of, first of all, for multi-network, what does this kind of problem does it resolve, right? That my understanding is it's because actually, my real understanding is there are like different kind of like service mesh that doesn't work, it doesn't interoperate, right? So multi-network sort of resolve that problem. My understanding is that, but and then if we implement multi-network, how do we make sure that when disaster happens, what needs to be done to make sure that the overlay network, assuming the underlay network is already taken care of, what does the overlay network need to do to make sure that?
Thank you. So in this case, again, it's up to the implementation. It's my go-to answer to everything. Because pod network is an API that just defines how things are configured by the CNI. That's how we position those new objects for multi-networking, and basically even for default network, right? Those are just parameters that then the CNI, the implementation, takes and implements that. So your question is more of on the kind of practical thing, how those implementation will implement this and how they will then recover, because I think that will be more the case. Because as I said, if control plane is still up, and let's say the nodes that are healthy can access API, they have access to all those objects, right? And so from our point of view, from the point of view of this effort that we're working here, we are always there, right? Our control plane, our readiness will be set because we know that the object is there and that it's ready, and the other objects are. Everything from that point of view is always there, and there is no issue with that one. So it's up to the implementation how they recover in such situation, right? How the implementation is going to behave when it spans those two across those two VMs, across those two physical places, and then if there is anything that needs to be synchronized between the two places, so that when one goes down, how to ensure the other one keeps being alive. And it's, again, implementation specific. Cilium copies most of the maps, eBPF stuff across the board. Some of it is held in Kubernetes API. The other is in memory. Whatever is in memory is per node and only for that node. So this is an example I'm giving, not specifically, but this is what I know of, because in Google we use a lot of eBPF and Cilium. So I'm bringing that up as an example. But there are other ones that do their own stuff. So Victor, I think this boils down to the implementation, and I don't think an API matters in this case, unless it's of course the failure of the control plane itself. So this is something that then the platform provider, the cloud provider, or whatever the platform provider, how they can ensure, because at that point I don't think Kubernetes can be resilient or do anything if your control plane goes away, right? Because then it's really dependent on the platform to ensure that you can replicate things. At least that's my opinion. Anyone has some other takes on this? No.
No, I agree. I mean, I agree with what you said, Martin, because I think there's nothing new for multi-networking with respect to disaster recovery, as far as I can tell, right? Of course, you have more, there's more objects, but apart from that, it's similar, right?
Yeah, I provide you the configuration, the spec, how it should be. But the implementation and basically the practicity of this, then it boils down to implementation and how they would handle that disaster recovery, right?
Will be helpful even if it's that, as you said, the actual implementation. So my understanding is multi-modal working is really kind of API specs for how to do this, right? So actual implementation, there's a lot of details each implementation can decide. But it will still be helpful actually to spell that out, at least for me, so that, if I look at it multi-net, okay, so let's say if I build a network a platform using Kubernetes, and then I choose multi-net, Multus, and then what kind of options do I have? What should I be consider? Like you said, like the control plane need to be available. But what if the control plane itself become part of that disaster? It got what can be done to
so then that is up to the, I assume, up to the and I'm just we kind of going off the regular our workforce topic, but I would just assume that's up to the platform provider, right? How they be able to back up the etc stuff to ensure that you can have the API pieces kind of recovered, and then how you would could recover and reinstate the control plane nodes, right? So that's and this is completely outside of the scope of Kubernetes itself, because it's impossible for it to heal itself in that matter, at least for control plane, right? At least that's my opinion on this. Yeah, there would have to be some sort of external piece that will monitor your control plane and then be able to restore it, right?
Got it. I have some general idea on how DR is handled. Yeah, thank you.
Sure. I think we are at the time. All right. Thanks, folks. I'm gonna try to add that drain kind of field into the object and tag you, or I will ping you on the Slack channel to let you know that I added that. All right. Thanks everyone.
Thanks all. Bye.
Bye.
Thanks. Bye.